Hello everyone, my name is Byung-hyun John and I'm going to present to you guys a paper called Is Endowment Effect an Expectation Effect? Written by Ori Heffetz and John A. List. Did anyone had an experience where you value an object that you actually possess compared to the case when the object is not obtained by you? People tend to give more value to things that they have, and this is called endowment effect. The motivation of this paper is as follows. The first paper on endowment effect was written by Nash. In Nash's paper, people were randomly given either a mug cup or a chocolate bar. Given each object, people were then asked if they would trade what they have with what they do not have. The result was that participants required a compensation for the mug cup once their ownership of the mug had been established. It was approximately twice as high as the amount they were willing to pay to acquire the mug. And this can be explained by loss aversion. People wait more to lose than to gain. Next, the question raised by this paper starts with the paper written by Kozeki and Robin. From now on, I will refer to this Kozeki and Robin's paper as KR model. The KR model explained the endowment effect with a model based on expectations. KR model combined the model with a theory of reference points that are determined by expectations. Simply said, a person's reference point is the probabilistic beliefs they held in recent past about outcomes. Therefore, KR model explains both the finding of original endowment effect suggested by Nash and the result that this effect shrinks or disappears in some experimental environment. And this paper now conducts an experiment to disentangle expectations to compare the effect of expectations with that of other variations. Heffetz and List's paper directly manipulate expectations, making it disentangled from endowment. This leads to clean test of the model without making assumptions regarding the environment-dependent link between endowment and expectations. It consists of 3 experiments, and each experiment is constructed differently with different factors and procedures. However, all 3 experiments are aimed to assess if KR model explains Nash's endowment effect. The first experiment has a 2-by-2 matrix consisting of assignments and expectations conditions. The assignments are coin mug versus coin pen. People are to choose one between a mug and a pen. Then they are asked to flip a coin. If coin is head up, they get a mug cup, and if a coin shows tail, they get a pen. However, what they actually get is determined by expectation conditions. In weak expectation conditions, subject will receive an assigned item by a coin flip with 1% probability, or they get what they chose beforehand with 99% probability. By contrast, in strong expectation conditions, the probabilities are reversed. They get assigned object with 99% probability, and with 1% probability they get to choose. And this slide shows results by expectations treatment. They show that the difference 13% in choice proportions across coin flip assignment conditions cannot be explained by expectations. The difference in proportions in the strong expectation treatment is half that in the weak expectation treatment, 8% and 17%. According to KR model, the difference between people who were assigned a mug and chose a mug in weak expectation and strong expectation conditions should be negative. This means under strong expectation, more people should have not changed their mind than in weak expectation conditions. However, the result, 12%, is positive. Therefore, the result goes against the KR model. To summarize, results suggest that while coin flip assignment could affect subjects' choices, it does not do so in the strong expectations treatment. Moving on, the second experiment is different from experiment number 1. First, the probability is now 10% and 90% rather than 1% and 99%. Also, there are two more factors. Less endowment here and more endowment. This is endowment language. Under less endowment condition, there is no certainty of obtaining an object. People are just told you will be able to choose which item to take home. In contrast, under more endowment condition, however, there is strong sign of possessions. Subjects here are told that the items are theirs to keep. And the result of second experiment is as shows. First, the leftmost column shows that overall, coin flip assignment affects choice. The difference between the proportion of mug choosers among coin mug versus coin pen subjects is 22%. Second, the next two columns show no evidence that the difference is larger in the strong expectation condition than in weak expectation condition. Here, 11% is less than 31%. This is also contrary to KR finding. And finally, as the rightmost column shows, the differences in proportion of mug choosers across expectations conditions are opposite in sign to KR's prediction among both coin mug and coin pen subjects. They have different signs here. However, under less endowment, the difference between weak and strong follows KR model. Here, 1% is greater than minus 18%. In conclusion, this result provides additional evidence we found by experiment number 1. And additionally, by adopting endowment language, we can get a result that follows KR model, which is a condition under less endowment. Next, the third experiment has the same probabilities as experiment number 2. The experiment is identical to the Moore endowment condition in experiment 2, except that the randomization into expectations condition is both transparent and made clear to subjects throughout the experiment. Subjects flip a coin and also a chip, and this chip determines the 10% or 90% expectation conditions. The result is as follows. First, in the leftmost column, coin flip assignment affects choice. The overall difference between the proportion of mug choosers among coin mug versus coin pen subjects is 12% here. And secondly, in the next two columns, we find no evidence that the difference is larger in the strong expectations treatment, 8%, than in the weak expectation treatment, 16%. And the rightmost column shows statistically insignificant expectations effects. Among coin mug subjects, the effect, 8%, is opposite to KR's prediction. And among coin pen subjects, it is nearly 0. To sum up, through these three experiments, we find, first, that assignment can affect choice in a way that is not easily explained by KR, nor by the standard model. And second, we find no evidence of a meaningful KR effect of expectations on choice. And this graph here shows the conclusion. And thank you for listening to my presentation. This is the end of my presentation. And if you guys have any questions, just leave a comment below and I'll try my best to answer them. Thank you.